Hello, I'm Luther Walk, Product Manager for Smart Plant 3D. I'm going to be talking to you about 3D Workshare on capital projects. As attested by JGC Corporation in the previous presentation, as well as by several other production users, Smart Plant 3D's global Workshare configuration is a solution that has proven to be highly robust. As such, 3D users are well positioned for executing projects requiring work to be shared across organizations within the enterprise. That being said, the 3D work sharing requirements of today's capital project market continue to evolve in an increasingly rapid manner. Intergraph is working aggressively to provide equally powerful solutions in response to those changing needs. There are several types of distributed workflows required on projects. As has already been stated, centralized data-centric Workshare is well covered by Smart Plant 3D's innovative, industry-proven global Workshare configuration solution. However, there are other workflows to which it may be less ideally suited. One example of this is parallel or sister design workflows. These are a type of design reutilization. Examples of this can run the gamut from batch reactor units in a fine organics production facility to the design of sister ships in a shipyard. In either case, and in fact in any parallel design scenario, there tends to be an inflection point. That is, a point wherein the parallel designs must diverge from one another. At this point, the 3D data behind the design must diverge as well. In some cases, such as with the parallel process unit design, this means the data must be merged into the same 3D model database. In others, the 3D data must be split into independent databases. A second example of a distributed workflow involves realizing the value associated with centralized designs. Also an example of design reutilization, it takes the concept to a higher level of error reduction and standardization, that of standardized modules. These are units of 3D data that are typically controlled by a central corporate entity and used on multiple projects. They tend to evolve over time as required by business considerations. However, the associated changes are implemented in a highly controlled fashion and affect only future and/or ongoing projects using the data. As with sister design scenarios, there can be a point wherein the local design needs to diverge, typically in modest fashion, from the centralized standard module. Intergraph recommends that this localized flavoring of the standardized module be identified and that portion of the design removed from the standard module where feasible. A final type of distributed workflow that is becoming all too common is that associated with joint venture projects. The 3D functional requirement associated with this workflow is oftentimes referred to as disconnected Workshare. It is called this due to the disconnected nature of the 3D data sharing that takes place as a result of various corporate entities partnering on the same project. Characteristics of joint venture projects are disparate domains and the associated issues with IT infrastructure, trusted domains, firewalls, etc., requirements for IP protection and adherence to security policy, disparate corporate standards for database platforms, varied 3D catalog requirements, also an IP issue, and even the requirement to use Smart Marine 3D on a portion of the project and Smart Plant 3D on another, and/or utilize different versions of the software. When discussing disconnected work sharing of 3D data, it is important to note that there can be two types with regard to the solutions being used. As shown here, the first is homogeneous, wherein the same 3D application is being utilized throughout the project, Smart Plant 3D, for example. The second is heterogeneous, wherein more than one 3D solution is utilized on the project. In the coming release, Intergraph Process Power Marine is delivering a high-value solution that is both simple and flexible. It is rare that a solution which is flexible is also simple. This is because flexibility is oftentimes driven by high levels of configurability, which tend to make a solution complex. However, as you will see in the next few slides, this solution is truly simple, yet, at the same time, highly flexible. In version 2009.1, the Smart 3D products will be delivering a solution known as Reference 3D, or R3D for short. This will be very powerful and will allow your organization to consider workflows that were not previously possible. As a result, you will be able to bid on a greater number of projects and do so with low risk and even lower cost. What has allowed us to deliver such a powerful solution in the compressed time frame of a minor release is the extension of proven technologies to a large extent. These technologies come from two sources, Smart Plant Review and Smart 3D. These capabilities are combined to deliver a solution that can meet a broad spectrum of 3D Workshare needs. Let's have a look at this. To demonstrate the new capability coming in V2009-1 of Smart 3D, we're now going to see a video demonstrating one of the types of 3D Workshare that was just discussed. This is a conceptual demonstration of a parallel design scenario wherein a batch reaction unit is replicated within the same project. This will be done for a total of 7 additional units. Again, in a parallel design or sister design scenario, there is a point of divergence, at which time the sister design or designs can no longer be worked on in parallel. We will discuss how the data is handled at that point in a later slide and video. At this juncture of the project, we have a single batch reactor unit that is being designed in SmartPlant 3D. So Unit 1 that we see here is fully intelligent S3D data. Now let's see how we can create some R3D data and use that for a parallel design workflow. This is done via the drawing console. It can be brought up in any of the S3D tasks. Once published, we see the view and ZVF files that have been dropped into a designated directory. Now we go into the project management environment and define a new R3D reference for the project. The software opens a form which allows the user to define the R3D reference. We return to our 3D graphics environment and have a look at our workspace definition. Accepting this form and allowing the workspace to update, we see a replication of the unit appearing adjacent to the master. Notice when we hover over the R3D data, the software indeed identifies it as such. This demonstrates the basic concept. We're going to repeat it again with the same data to form 2 additional units. We're going back to the project management environment in SmartPlant 3D and create another R3D data set that is rotated 180 degrees. Returning to the 3D graphics environment, we check our workspace definition and see that all that is needed is a refresh of the workspace, and we see this unit coming in across the designated thoroughfare from the master unit, or Unit 1. We will go on to repeat this for 3 additional units, such that we have a total of 8 units, 7 of which are R3D datasets, which have been transformed and or rotated. We can see this in project management. Once the definitions have been created, however, there is no requirement to revisit the definitions in the administrative environment. Let's see how this works. Again, in the 3D task environment, we do not need to modify the workspace definition. All that is required is to perform a refresh, and we see the final 3 units coming in. At this point, we have our sister units defined, and again, this is the first and last time we will have to do this. Now let's look at how changes to the master unit are propagated. As we apply these style rules, we see only the first unit is impacted. Again, it is the only unit comprised of fully intelligent S3D data. The other 7 units are R3D attachments. As we zoom into Unit 1, we also see additional piping, valving, and instrumentation has been added to Unit 1, which does not show up in the other 7 units. So how do we see the changes in the other units? This is very simple. We simply republish the data and refresh the workspace. As we did in the initial publish, we invoke the drawing console. Note the exclamation point. Smart 3D has recognized that this data is out of date and as such requires a republish. So we do just that. Then we simply refresh our workspace and watch the magic. All of the changes to Unit 1 are propagated over to the other 7 units. This includes the style rules, the additional instrumentation, the changes to piping, including additional valving and pipe components. And at this point, as we zoom in, we see that indeed the units are all identical. The utility of this type of capability is quite powerful, and the different workflows it enables are substantial, maybe even unlimited. And again, it's very simple. As we discussed a bit earlier, any parallel design workflow tends to reach a point on the project schedule that might be described as an inflection point. That is, depending upon the specific workflow, the design needs to diverge. The master design and the child designs can no longer be kept the same. In our example, some of the reactors may be running reactions containing chlorides. This moves the design away from stainless steel towards glass-lined equipment. This may be for the reactor only, or perhaps the reactor, the filters, and associated piping, or it could be for the entire reactor train. Whichever the case, the engineers on the project will decide at what point the design must diverge, and it is at that point that the 3D data representing the design will be affected as well.